Okay, guys, well, welcome back to resolving LeetCode problems. Today, we're going to go with the second problem, that is add two numbers. Add two numbers is one of a classic number where one of a classic problem where you have to use um, the two pointer algorithm, which is basically let's assume here that we have like a list. Okay, we have our elements, and instead of going comparing like one to this and this to this and this to this, we can actually place two, like one pointer here, let's call it I, and one pointer here, let's call it J, and we can like basically shrink the amount of time that you're going to need to like do comparisons or like to iterate over a list, used by adding another pointer to the problem. So well, okay, here's the problem. It's saying you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zero except the zero itself. Work here's an example. So this is a one linked list, this is another one, and this is the return that we have to give. So the input is going to be two linked lists, non-empty, and the output has to be another another linked list. This is also the reason why I haven't been able to upload. I've been sick. Um, and the output must be another linked list with the sum of the elements. So what it's saying here is basically like the following, right? Like, let's assume that we have, well, first, so what is a linked list, right? Because this is all about data structure. A linked list, as I told you before, this is like a regular list, okay? It's contain individual and contiguous elements, one right after the other, okay? A linked list, what it has is it has two, like, it has a node. This is like literally call it like node, and the node has the value and it has the pointer next of where the address of the next node is. So this is a node, and let's say that this is another node. This next, it's going to contain the memory address of the next node, and the next node is also going to contain the value and the next, and this all like until we reach the end, and the end is the value null. Once the next is null, that means that node, this node here, is the last element of the list. So that's like what it means. I'm seeing that my cat is like over here. And well, why do we need to know all of this? Because here is clearly saying that it's, you don't need to like define the structure. It's giving you the structure here. A structure list node has value and has the pointer to the next node. So the problem is that it's going to give us the next linked list. Is going to give us 3, let's say 3, 0, and 7, and then 5, 4, and 6. Okay, this linked list is in a reversed order. Here is saying reverse order. So these numbers are actually 7, 0, and 3, and this is 6, 4, and 5. What we're supposed to do here is that usually when you like go with sums on a paper, what you do is you go right to left. So you go 5 plus 3 is 8, 4 plus 0 is 4, and 7 plus 6 is 13. You're going to put a 3 here, and then you're going to have a carry. The carry is when you cannot, because this is like limited to zeros to nines, so this cannot be bigger than 0 and 9. So when you have a 10, what you're going to do is you're going to place the 0 and you're going to carry 1, and the carry you're going to put it to the left. So it's going to be this is going to be the result. But since all of this is reversed, actually the sum also is going to be reversed. So it's going to be from left to right. So this is going to be 5 plus 3 is 8, 4 plus 0 is 4, and 7 plus 6 is 13. You carry 1 and you get that carry down. You get the carry down, and the carry will be 1. So 8, 4, 3, 1, 1, 3, 4, 8. So as you might see, this is the exact same than this. Just that it's stored in a reverse order. So we have to figure out a way where we get the value of this list and this one. We get each element, add them up, and storage each of them onto our result, right? So a way to do that is also, one thing that we need to know is that we need to also have a method or a way on which we have the carry and that we have this number. And a method that I figured to do is oh my god, a method that I figured out that can work very well is actually using the modulo and the divider operator. So let's say, for example, that we have here the number 14. All right. Oh well, let's just for the sake of the exercise, let's say this is the 7. This is also like 7. I don't know. And in sum is equal to x plus y. Okay, so now I know that that's 14, right? But I don't want to write to 14 because again, the limitation is that it's from 0 to 9. So 14 is actually 4 and you carry 1. So the way that you place the value, this 4 down, is with the modulo. So like the value, it's going to be equal to sum modulo of 10. This is going to give us the remainder. The remainder is what we want. We want this one. This is the remainder, and this is going to be the carry. And the carry, it's going to be sum divided by 10. So if we want to like actually, because we want to prove everything, this is like sum equals number, and then like value equals like the number, another number, and then the carry is equal to another number. Okay, so this is going to be sum, this is going to be value, and this is going to be carry. So you can see it, right? Well, why does it have like this comma here? Oh, here it is. Okay, so this is what I'm saying. Okay, the sum of the numbers are 14. 7 plus 7 is 14. So the value that we're going to actually place on the linked list is going to be 4, this one, and the carry is going to be the left element, so the 1. So that we have to also translate it to our method. So we have to start like programming or like to coding. We already like made a lot of progress with the like drawings and understanding what a linked node is. And well, the modulo is the operation like of the remainder that you get, and this is a simple division to get the first unit, right? So we have to first, oh by the way, linked list, initializing a linked list, you have to do it manually the first time. You have to manually create the first node, and you have to make it point to the next node that is going to be a null. And since we're going to use the 2-pointer algorithm, we have to create a pointer to the original like header. So this is going to be list node head. This has to be a pointer, and this is we're going to ask for memory allocation of the size of whatever the size this is, which I can tell this is 4 bytes, and the pointer, I don't know how many bytes that might be. But well, we have, with this, we initialize a linked list. Now we have to manually create the first node. So the first node is going to be like the val, and val is going to be 0 because we have nothing there. It's just, we're going to actually like jump from the first node to the next. The next is the one who's going to start with the sum, with the return value. So head next is going to be equal to null, because null, there's nothing after this. And well, we have to initialize the carry, that's going to be 0, and we actually will going to need to initialize the second pointer. So this is going to be second pointer, and it's going to be something like this, current, and it's going to be head. Okay, so this pointer is pointing to this. So this is the one who is going to like move up until we like finish the whole thing. With move, you're going to see what I'm meaning to. So here's like the logic of the thing. I'm going to use a while because we need to think how we're going to like iterate over all of this. So while like I guess the list 1 is different than null, or the link 2 is different also than null, and we have to also think that the carry, because what something similar to happen here is that here's nothing, like this is 0 and this is 0, but there is nothing there. So if the carry is different than 0, you have to count the carry because you have to get that down. Okay, so that's going to be if carry is different than 0. And now we can proceed. So we have to first go with x and then go with y, and we have to get the value. We have to get the value of what x is and what y is. So x is going to be we can use the ternary operator here for this whole thing. So if let's say L1 is different than null, ternary, it's x is equal to the value. If not, it's equal to 0. And y is going to be, if L2 is different than null, then ternary L2 value is equal to y, else is 0. Okay, so we have to get the sum. Sum is going to be x plus y plus the carry. It's very important to also add the carry at the sum. And the carry, well, we already defined that. So carry is going to be equal to sum divided by 10. That was the thing, right? Sum divided by 10. Yeah, and the value. Okay. So we now have updated the carry. We have the sum, and now we have to actually start creating our return. So our return is going to be we have to use the second like the second pointer. So current, it's next, it's going to be, we have to create memory for this, so it's going to be size of, again, struct list node. So we have to create space for the next node, and the next node, current next val Okay, this is the next node value. This is going to be the operator. Yeah, the same thing. Some operator, some modulo 10. So this is the value here, and the next is going to be no. Okay, so next is equal to null. And now we have to move the pointer to the next node. So current, it's going to be equal to current next, maybe, or head next. Let's see current next to see what happens. I already did this, but I don't recall the exact code at the top of my head. So yes, this is moving. Okay, you have to think not in you have to be more imaginative with when you're reading C code. You have to think that all of this is moving. This is like a guy who is moving from place to place. This guy is basically doing all of this. Okay, so we have the header here, and we have the current. So current is going to move here, and he is going to create all of this, and he is going to move to the next node, and he is going to create this node, and so you need to have like a secondary pointer who is going to move to the next node, initializing that node, initializing the next with null, and then keep moving with the whole iteration. So this is like the whole what the current is doing. And now we have to figure okay, so here we have I think it's partially done, but we have to figure out a way of continuing the if yeah, because now we have to keep going, right? If L1 different than null, we continue. I don't recall how to do this, because I know that you have to finish the whole thing. In the meantime, let's see what happens. We have to also create what we're going to return. So we're going to return this list node. Let's say return, or result. And the result is going to be the head. A head next, actually, because the first is going to be 0 and null. So the first is going to have the value 0, and we want the next. The next is this one. This is like the first number that's going to start. Then now that we have that, we can actually free the memory from head, since we're only going to use result. And now we can return the result. Return result. This is maybe going to give us an error, because I know that there is something that I'm missing. Okay, it's taking too much. Yeah, it took too much. So we have to figure out a way of finishing this process here. And I don't exactly recall. Let's see here on the results. The implementation here is. Oh, okay. So yeah, we have to keep going. This is the thing. Okay, so I knew it. I knew that I was missing something. If link 1 is different than null, then we have to jump to the next node, because it's we have to keep moving. And the same thing for here for the L2. So L2, oh my god, I missed Vim. L2. So yeah, this is a way where you have to finish it, because if not, it's going to loop forever, I think. and it's actually not moving. It's going to do the first iteration and then it's not going to move. Now you have it. Yeah. Thank you, editorial from LeetCode. So yes, the solution is very simple. Let's submit it. Now I'm also like learning about, because I was reading that all of this might have like different or like better performances, like log big O n or something like that. I'm still like figuring out what that means. This one, like O max nm. Okay, so excellent words. The solution is already optimal in both time and complexity. Yeah. So it's not a very difficult problem. You have to draw a lot. It seems that we obtain like log big O log n. I don't know. I'm still figuring out how that works. But here the problem says medium, and I don't think that is a medium problem. I think it's medium if you don't know what a linked list is and you don't know how to deal with structures. The way you deal with structures is that you access the initializers, or like the, I don't know, the data using on C, this like I don't know, this thing here, this dash and bigger than, and then you get the val and the next. But it's not difficult once you learn the syntaxes of linked lists. The most difficult part of linked lists is understanding that this is not contiguous. This might be in a separate like block of memory completely, but if you have the address, you can place it on the next, and so it's going to know where the next node is. So yeah, that's it for the problem. And I see you guys on the second video.